Change the
不要
name.
让他自己签，你走了，把这张填了。你上楼去让他填。
How can I change my name?
写你的名字，是不是就可以了？
Slides.
Hide on mute. Okay.
So does anyone have any questions about the homework? Any questions?
看着你的那个人就完掉了。
Any questions? Homework? So it's good?
你到对看，别人不用看了，看他就行了。
My pen.
你游泳不安全，所以把那个把你的人头去掉，对。以后你们画这样的东西我都给扔了。这个东西你帮我跟你说了，把它弄回去。哎呀，这说的。这呀，这叶子都干了。你看谁吃的？这是给大家上去用的地方，你看搞的。
So good news, guys. I figured out how to use quizzes. So apparently last time I was working with a student account, so they wouldn't let me host a game. So then I made a teacher account, so now I can host game now. So hopefully it's gonna work today. So let me get my share screen up. You want to see the slideshow? Okay, so week 4 now. What we're going to talk about today are equations and expressions. All right, so I'm sure a lot of you already know what those are, and that's what we're going to talk about today. So let me just wait a little bit longer for people to come in. Okay, let me. Alrighty, expressions and equations. So the topics we're going to talk about today are, first thing is simplifying expressions. Then we're going to talk about solving equations, and then we're going to talk about solving inequalities. All right? So, simplifying expressions. Well, what are expressions? Well, expressions are just kind of math sentences, like regular sentences in English. These are like math sentences, except with numbers, obviously. So, for example, 3 plus 3, that's an expression. What's another expression? What about 4 plus 4 plus 5? So all of those are expressions. They're just math sentences here, okay? And if I introduce a variable x, so this x could represent any number here. So if I had x, then this could be an expression, okay? So an expression is any math sentence like this, all right? And remember back from the first lesson, we can raise x to some kind of power, for example, to the 4th power, okay? Another expression I could write is, for example, x to the fourth plus 3 times x squared plus 5, right? This would be an expression. So these are all examples of expressions, okay? So if I have some kind of expression here, what are the parts of this expression? Well, as you can see, there are variables here, right? These are just called variables. They represent some kind of number, okay? And then, as you can see here, we have separate items, if you would say, separated by plus signs, okay? And what these separate things are called, they're called terms. So for example, in this expression, we have 1, 2, 3 terms, all right? And then the numbers in front of coefficients, in front of variables, they're called coefficients, all right? So what's the coefficient here? It's just a 1, okay? So these numbers are called coefficients, and the normal number we have, like normal number, just a number that we know without any variable, this is called a constant. Okay, so those are parts of an expression. Okay, so sometimes we're given expressions really long. Something like this. Okay, and we want to make this one simpler, right? Because we don't really want to see this much on our page. Okay, so how can we simplify these? Well, one thing we can do right now is add these constants together, because 6 minus 5, well, I can do that, right? 6 minus 5, that's just 1. So we're going to have some kind of plus 1 at the end. Well, what can I do with these x's? Well, what if I pretended these x's were apples? Right? I have apples here. If I have 5 apples plus 5 apples plus 3 apples, 13 apples, right? And since x represents apples, 13x. Okay, so this is how you would simplify this kind of expression. Well, what if I put in something like 4x squared plus 3x squared? Well, now x to the second power, that's not the same as my x here. So these are not apples. These are different from apples. We can call these like bananas. Right? So we can't add these to any of the apples here because bananas are different from apples. But we can add stuff that are bananas, right? We have 4 bananas plus 3 bananas. That's 7 bananas. Okay? So this means we're adding these terms that have the same power of the variable. See that? These are both x, these are all x to the firsts. All right, so what we call this is, we call this combining like terms. Okay, so we see that there are like terms here. All the terms with x squared in it, we can add those together. All the terms with x in them, we can add those together. But we can't add between these groups, right? We can't add apples and bananas together. All right, so that's how you would simplify an expression. So let's do these 4 simplifications here. You guys, maybe 4 minutes to do. 1 minute for each one. Okay, so if you get an answer, please, maybe you can private that one to me, because we want to give everyone a chance to do the problems. Oh, I'm getting a lot of responses here. Oh, Sorry if I can't respond to all of these. There's a ton here. I'm just going to go ahead and explain these now. First one, I see a 4y minus 5, then I have this in parentheses. So this calls for the distributive property here. Because I have a minus 1 here, and I have to multiply this to both terms inside the parentheses. Okay, so I have 4y minus 5, and I have a negative 1 times 3y. So that makes a negative 3y. And now I have a negative 1 times a negative 6, which makes positive 6. Now I can combine like terms. I have these y's here that I can combine. 4 minus 3, 1y. And have negative 5 plus 6, 1. And so the 1 can basically go away. So the answer is y plus 1. All right. Now for the second one over here with the fractions, this problem. Well, one thing I can do is I can use the reverse distributive property. I can take an x out of both of these. Some of you might know this as factoring. I can take the x out of both of them. So I basically reversed the distributive property here. I did the opposite of distributing. I took it out. All right, so now I have these fractions being subtracted from each other. And from last class, I need to find a common denominator, right? And seeing the LCM of 7 and 3, that's 21. So to get 7 to 3, I need to 7 to get 7 to 21, I need to multiply by 3 on top and bottom. And to get 3 to 21, I have to multiply by 7. Does everyone understand how that works? All right, so now I have 15 over 21 minus 14 over 21. And when I subtract these, I only subtract the numerators. I don't subtract the denominators. This is 1 over 21. But we can't forget this x here that's being multiplied. This is the answer. And an easier way to see this is probably x over 21. Okay. Now for this one, the third one right here, this is kind of tricky. Right? We have fractions, but we have variables. And this numerator is kind of wacky. So how do I add these? Well, let's pretend that these are just normal fractions. Well, I have a 2 here and a 4 here. I just need to get them to the same denominator, right? And the LCM of 2 and 4 is 4. So I don't need to change 4. I'll change this one and multiply 2 on both, on top and bottom. So I'll get 2a over 4 plus 6a plus 5 over 4. Okay, and now this is just like adding fractions, right? We add the numerators together and we keep the denominator the same. So if we add 2a to 6a plus 5, that gives us 8a plus 5 over 4. Okay, so this, you can keep it like this. This is pretty simple. Or you can divide 8a by 4 to get 2a plus 5/4. Okay, but this answer is a lot simpler to look at. And I'll accept both of those. All right, so let me clear some space. For the last one here, well, if we see here, we have a z, a y, an x, and a constant. I can't really combine any of them together, right? So this is already the simplest it can be. Okay, so that is the answer. The easiest one out of all of these. Okay, are there any questions on how that works? Any questions? No? Okay, cool. Now solving equations. Well, equations, what are equations? The definition of equation are two expressions on different sides of an equal sign. So if I have an equal sign here, I'm going to have some expression here, another expression on the other side. This is the definition of what an equation is. And sometimes we're going to have variables in equations, and problems are going to ask us to solve for those. So what am I talking about? If I have something like x plus 10 as an expression, and I equate, if I take that as equal to 15, well, how do I solve for x here? Well, if we use logic, well, we can think that, hey, why don't we just guess numbers? And yeah, if it's simple like this, then it should not be that hard to guess the answer. But we want a more mathematical way to do these things, okay? So the strategy here is to get x by itself, okay? If we somehow get x by itself on the equation, then we have some number here that equals to x, and then we'll know what x is. So basically we want to get x by itself. But right now we have a plus 10 right here attached to our x. So how do we get rid of this plus 10? Well, we can minus 10 because subtraction is the opposite of division, of addition, right? So if we do plus 10 minus 10, that's a net change of 0. So then I'll have x by itself on this side. But the important thing to remember is that we have to minus 10 on the other side. Well, why is this true? For example, if I had a balance here, and I had x plus 10 on one side, 15 on the other side, right? If I subtracted 10 on this side, then this side is going to be lighter, right? The left side is going to be lighter, and the scale is going to tip forward. So it's not going to be balanced anymore. So what can I do to balance it? I'll subtract the same thing on the other side. Okay, so if I do this now, then I'll have x plus 0, basically doesn't change anything, is equal to 15 minus 10, 5. Okay? Another example of this is if I were to do 4x equals 32. Well, we have a 4 times like tagged onto our x here, and we want to get rid of that, so we have x by itself. Well, we can divide through by 4 because that's the opposite of multiplying by 4, and these will cancel. We'll get x equals 32 divided by 4, which is 8. Okay? What if I had a more complex equation here? What if I had something like 3x minus 6 equals 18, for example? Well, do I get rid of the 3 times x first, divide through by 3? Or do I subtract 6 if I get rid of the minus 6 first? Well, which one do I do? Well, the thing is, both of them are actually going to work. It works for both of them. But the easiest way is to use the reversed order of operations, okay? We know what the order of operations is. That's the PEMDAS thing, okay? And reverse order of operations is SADMAP. Okay, say that, SADMAP. It's a pretty funny name, okay? So when we're doing solving equations, we're going to use SADMAP. Okay, so we're going to do addition and subtraction first, then division and multiplication, then exponents, then parentheses. Okay, so if we follow the SADMAP procedure on this equation, we're going to want to get rid of the subtraction and addition first. Well, that means we're going to have to get rid of this minus 6 here. How can we do that? We add 6 on both sides. So we have 3x equals 18 plus 6, 24. Now I can divide through by 3, because a 3 times x, how to get rid of that is by dividing by 3. X equals 8. Alrighty, So that's how you would do more complex solving equations. All right, SADMAP, reverse order of operations. Okay, so here are a few problems for you guys. So please don't put your answer in the chat. Please private that to me. Give your answers to me, please give them as improper fractions because we don't really want to work with mixed numbers here. Fractions are always better than mixed numbers. Please don't write your answers in the everyone chat because we want to give everyone a chance to do these problems here. I'm just going to explain these in about 1 minute. Okay. Okay, so the first problem is pretty straightforward. What we're going to do is we have a -9 attached to our x here. When we want to get our x by itself, then we'll know what it is, right? So how do we get rid of a -9? Well, +9 gets rid of a -9. So now these go away. X equals 10 plus 9, 19. All right? So be careful here. I saw a lot of people did this. They -9 both sides. Well, it kind of gives the illusion that a 9 minus 9, the same thing will cancel it, but no. We have to do the opposite operation here. See how minus and addition are opposites? So that's how we're going to do that. And now for the second problem. One thing that I would like to add to the SADMAP. See, someone has a question. Okay, Andrew, do you have a question? So instead of having SATMAP, one thing I would like to add before that is the distributive property. Pretty funny to say distributive property SATMAP, but distributive property is what we want to do before we do SATMAP. Okay, so a good example of this is if I had 7y minus this thing here, I can distribute the 7 to the y and the 9. Okay, doing the distributive property makes everything a lot easier to solve. Okay, if I were to do that, then I would have 7 times y, and then 7 times -9, -63 equals 80. And now, using the SATMAP, I'll have to get rid of this -63 first, which means adding 63 on both sides. This all goes away, and I have 7y equals, well, 80 plus 106 plus 63 is 143. Oops. And now I get rid of the 7 by dividing through. So y just equals 143 divided by 7. Okay, and this is the answer I like to see. I like to see an improper fraction. All right, now let's do the last problem here. Well, the first thing I can see here is that I have a lot of like terms in this one, right? I have a 3y and a 6y that I can add together and make things simpler. Okay, so I'm gonna simplify this expression first. I'm gonna combine the y's and add them together to make 9y. And I'm gonna do 9 plus 9 to get 18. And now for the other side, I'm gonna distributive and use the distributive property to get 10y minus y and then minus 7. Okay, and as you can see here, I have two y's here. Now I can combine these like terms. 10y minus y turns into 9y. Well, look, we have two dyed y's on both sides. We get rid of them because we can balance it out. If you want to see how this actually works, if we can minus 9y on both sides, the equation is still valid. And then these just go away. So our final answer is 18 equals -7. But wait a second, this is not right, because 18 doesn't equal -7, right? So what do we do wrong here? Well, we actually didn't do anything wrong. This is a false statement. Okay, so what that means is that there's no solution as y. There's no answer. So no value of y will ever work for this. If you really want to try it out, you can plug in y as 0, 1, 2, 3, 4, even a million. It's not going to work. Okay, so there's actually no solution to the last one. This says no solution, because this equation is definitely not correct. Okay, so whenever you have that kind of situation, don't stress out about it, because it might be that there's just no solution. So now we have some more advanced equations. Okay, there's a really common problem that there is, like this. 3 divided by x equals 10. Well, now I have x in the denominator. Well, what do I do here? Well, the key here is that when we solve equations, we want to get rid of all fractions. Get rid of the fractions, because we don't like to work with fractions. It makes things a lot complicated. So how do we get rid of this 3 divided by x as a fraction? Well, since x is the denominator, we can multiply both sides by an x. This effectively eliminates the denominator from this fraction. Then we just have 3 equals 10x. All right, so now we just have a regular equation that we can solve by dividing through by 10. All right, and there are some other more advanced equations, such like x plus 4 over 3 equals 3x plus 2 over 4. Okay, we have two really wacky fractions here, and we really want to get rid of these, right? So how do I get rid of this 3 in the denominator first? So first I'm going to look at the first fraction. I'm going to completely ignore what's going on with the other one. Okay, so how do I get rid of this divided by 3? Well, I'll just multiply 3 on both sides, right? This gets rid of this denominator here, and now I just have x plus 4 equals 3/4 times 3x plus 2. Okay, does everyone see that working? Well, now I have 4 in the denominator over here, right? I want to get rid of this. So what do? I can multiply both sides by 4. This goes away, so 4 times x plus 4 is equal to 3 times 3x plus 2. At this point, this is just a regular equation. I can distribute it and do the SATMAP. All right? So with a lot of the more advanced equations, we're going to see fractions involved. And what we want to do with that is we want to get rid of the fractions as quickly as possible before we do anything with SADMAP. All right? So here are some of these problems. Give you some time to work on these. Maybe skip the last one here because we're running a little low on time. So please don't put your answers in the everyone chat because we want to give everyone a chance at this. So if you're having a little trouble with these problems, what I recommend is always focus on getting rid of the denominators in the fractions that you're given. Maybe one more minute. I'll go over these problems here. Alrighty, so the first problem, it might look a little complicated here. So what do we do? Well, we have a denominator here, and based on the fundamental law of getting rid of fractions, we're going to try to get rid of fractions here. So what I can do here is I can multiply both sides by this whole 2y minus 3 chunk. Okay? Doesn't matter how complex this denominator is, as long as we can get rid of this denominator, it's going to make our problem a lot simpler to solve. So these two go away. So 3 equals 10 times 2y minus 3. Now, distributive property first, then SADMAP. I'll distribute. 3 equals 20y minus 30. Now I do SADMAP. I'll add 30 on both sides. 33 equals 20y. Get rid of the 20 by dividing. 33 over 20 equals y. All right? Are there any questions on how that works? So the big critical moment in this problem is to get rid of the denominator here. All right? Now for the second one, as we can see here, we can look, there's a 5 and a 3. Okay? So the first way to do it is, as I said, focus on one fraction first. But then we have to do this process 4 times, right? If we multiplied the entire thing by 15, well, what would that do? Well, that would get rid of all of these denominators, right? Because 15 will cancel with all of them. So a good trick here is to look at the LCM of all of the denominators, 5, 3, 5, 3, and then we multiply the entire thing by that. All right, so if we multiply the entire thing by 15 here, then for the first term, this is going to go away. And then we're going to have a 3. This is going to go away. We're going to have 5 times 3 times 5. Okay, because if we cancel this, then that's going to be what we get. So 9 times 3 minus 2x times 5 equals 6x times 3 plus 7 times 5. Okay, so what do we have? 27 minus 10x equals 18x plus 35. Alrighty, so what can we do? We're going to add, do this. We're going to, well, what do we do here? Well, we want to combine like terms. We have an 18x and a 10x here. So what I can do is I can move the negative 10x to the other side where I can combine it as a like term. So if I add 10x on both sides, these go away. So now I have an 18x plus 10x, and I can add those together. 28x plus 35 equals 27. Okay, so now I use SADMAP. I minus 35 on both sides. 27 minus 35, I think that is 8, equals 28x. And now I divide through by 28 to get rid of this 28 times. All right, so my answer is negative 8 over 28 equals x. And now to simplify, I'll cancel these. 8 turns into a 2, 28 turns into a 7. X equals negative 2 over 7. All right, are there any questions? So with these complicated equations here, what we want to do is get rid of fractions. That is our top priority. Now, the last thing on our list is inequalities. So sometimes instead of having x plus 10 equals 30, we might have something like x plus 10 is less than 30. All right, so how do we solve something like this? Well, actually, all the same rules apply. All the same rules for solving equations are the same for inequalities. So for this one, I can just subtract 10 on both sides. I'll get x is less than 20. And that's going to work. But there's only one thing that you have to remember here. When we're simplifying like this, and we're getting rid of these, getting rid of stuff on our x, if we multiply or divide by a negative number, then we have to flip the direction of the sign here. So, as an example, if I had negative 3x equals less than or equal to 30, and I divide through by negative 3, I'm going to have x is greater than or equal to negative 10. All right, so whenever we multiply or divide by a negative number, we're going to have to flip the direction of the sign. All right? So why does that work? Well, if we start with something like this, which we all know is true, 7 is less than 9, and if we times -1 on both sides, we're going to have to see how -7 is greater than -9, right? If we didn't flip the sign, our equation wouldn't be right, because otherwise we would have -7 is less than -9, but clearly that's not right. Okay, so this shows how this works. We have to flip the direction of the inequality symbol here if we multiply or divide by a negative number. Okay, if we multiply or divide by a positive number, that doesn't change anything, and addition or subtraction doesn't change anything either. Alrighty, so that's the only thing we need to basically remember for inequalities. That's the only difference. So everything else is the same. Let's skip this one for now. I don't think these should take that long. It seems like we're running low on time here, so maybe I'll go for 1 more minute of work time and then I'll go over these. Okay, I'm just gonna go over these now. So if we look at this one, we can just pretend it's an equation and we can just solve it like as if there was an equal sign here. But we just have to look out for multiplying or dividing by negative numbers because that's going to make us flip the inequality sign. Okay, so first we're going to add 10 because of SADMAP. 3x is less than 27. And when we divide, since we're not dividing by a negative number, then we don't need to flip the direction of the inequality symbol. These will cancel, so x is less than 9. All right? Now for the second one here, we're going to divide by -4 to get rid of the -4 times to our y. And what that's going to do is that we have to flip this now because we're dividing by a negative number. So I get y is less than or equal to -8. Okay? So when we multiply or divide by a negative number, we have to flip it. Alrighty, so that is the end of the PowerPoint. And now we're going to do the quizzes. So let me first share my screen here with this one. Can you guys see this? So here's the quizzes. So you guys can go to joinmyquiz.com and enter in the game code 795845. All right, or I can take this code, copy link. Okay, I see some people are coming in. So I'm going to post an overall link. If you don't want to go to joinmyquiz.com, you can directly click on that link and I think it will take you there. Music? No, no music? Okay. I have 36 people on class, so I think we should have around 36 people in the end. Right? Does anyone have any trouble getting in? So you guys can see my screen, right? So live leaderboard is going to be on there. Maybe one more minute of waiting, and then we're going to start the game. So I'm sorry if this is going over class time, because we're only supposed to go for 40 minutes. So if you really need to leave, then that's okay with me. If you want to do the quizzes, you can stay. All right. So, oh, someone's the join code right here, this guy. Okay, I'm just going to start the game. 10, 9, 8, 7, 6. Oh, someone new. 6, 5, 4, 3, 2, 1. Last call to get in. Okay, good luck, guys. So we have, all right. Sabrina is up on top with a streak of 3 right questions. Ooh, two other people have gotten a streak of 3. Jonathan and Gavin. Sophia also with 3. Rosie also with 3. Eileen with 3. Brendan with 3. Ooh, Eileen up to 4 correct questions, along with Gavin and Jonathan. So Brendan is there. Oh, Andrew also with 4 correct. And Eileen is up to 5 in first place. Brendan also with 4 correct. Andrew has moved to top. Jonathan with all correct. Andrew up on top. Eileen back on top. Andrew. Seems like Andrew and Eileen are fighting for first place right now. Jonathan is 3rd place with all correct so far. Andrew is pulling ahead. Andrew is finished and he is in first place. Jonathan still has no incorrect answers. Andrew is still at top. Let's see if someone can beat him or not. Let's look at these questions. Ooh, this challenge one. Okay, doesn't seem like anyone will be able to beat Andrew at this point. Ooh, Jonathan still up and running. Ooh, Amy just jumped up a lot, now in 5th place. So Jonathan is right behind Andrew now. It seems like Andrew is undefeated still. So I know it's getting late, guys, so if you need to leave now, then that is fine. Ooh, Jonathan on his last question, I think. Let's see if he can beat Andrew. Ooh, Jake with a perfect run right so far. Ooh, Jake. It seems like Jake might be able to beat Andrew. Oh, Jake is now in first place. Jake has, I think he has one more question left. Oh, Jonathan. Jonathan has a perfect game. Ooh, Jake. All right, so it seems like our clear winners are Jake in first place, Jonathan in second, Andrew in third. So I'm going to end the game right here. Third, Andrew. Second, Jonathan. First place, Jake. All right. So there was one of these challenge problems that I would like to go over. So number 7, this is probably the least amount of correct answers here. So this is actually kind of a weird problem here. If you guys want to see me do it, or if you really need to leave, then okay. But I'm just going to explain this challenge problem here. So let me write it again here. So the challenge problem is 1 over n. I think it's greater than or equal to it. Let me check. Yep, greater than or equal to 1/6 actually. All right. So what I can do here is I want to get rid of fractions, right? I'll multiply both sides by n. But wait, since this is an inequality, what if n was negative? Then if n was negative, then this would have to be flipped, right? So there are two cases we have to consider here. The first case is that n is positive. So if n is positive, then we don't have to flip it. All right, so if n is positive, then we have 1 greater than or equal to 6n, divide through by 6. 1/6 is greater than or equal to n. Okay? So in other words, n is less than or equal to 1/6. So now we need to consider the other case, where n is negative. Because if n is negative, then we're going to have to flip the sign here. So when we multiply through by n, we're going to see here that then 1 is less than or equal to 6n, n is greater than or equal to 1/6. But wait, if n is negative, then n can't be greater than 1/6. Okay, so since these two things are contradicting, n can't be negative. Okay, so both of these are not true. N is not negative. Now we've figured out that n is less than or equal to 1/6 if it's positive or if it's 0. But now we need to consider 0 here. Does 0 work for this question? Well, if we see here 1 divided by n, if we plug in as 0 for n, we can't divide by 0. So 0 doesn't work either. So our other limit here is that this has to be positive numbers, but it can't be 0. So this is the final answer. All right? This is kind of a more advanced casework problem here. Alrighty? So thank you guys for coming to class. And I'll send out the homework. And see you next week. Bye, guys. Have a good week. Have a good Sunday. Bye.